In this video, we're going to cover Euclid Book 2, Proposition number 3. And it's always very important to continue watching these videos one after the next and not skip anything, because I may include details in a particular video that you might find vital in future videos. Now, if you've watched Euclid's Book 2, Propositions 1 and 2, you may still be questioning what it means by is contained by. Okay, this is a rectangle here. It is A, F, D, C. And this rectangle is contained by the lines AC and AF. Okay? Now, what does Euclid want you to do? Alright. First of all, he's going to want you to draw a straight line AB, and he wants you to pick a random point at C, and he wants you to cut off AB at point C. Okay? And that's all you're going to do at this point. Alright? Then he's going to have you draw a square with length CB right here. And that square is going to be CDEB. Now, do you remember how to do that? If you don't, go back to Euclid Book 1, Proposition 46, because that's how I teach you how to draw a square. Alright, once you've drawn this square, Euclid then wants you to extend line ED out to F, and then he wants you to draw a parallel line between F and A. And this parallel line has to be parallel to CD and BE. Okay? And not only is it going to be parallel, but it's also going to be equal in length. Okay. Then Euclid says that he wants you to prove that the rectangle contained by ABBC equals the rectangle contained by ACBC and the square of BCDE. Well, here's BCDE. Alright, how are we going to do this? Well, we've already drawn the square here, and we've drawn all the lines. Now, we already can say here that AFEB, this whole rectangle right here, AFEB, is the sum of the rectangle AFDC plus the square of CDEB. But now he's going to state it a little differently. Okay? AFEB, here's the AFEB, okay, is the rectangle contained by AB and BC. AB and BC. Now, how can he say that? Well, because the length of BE is equal to the length of BC. Okay? So, he can say that this is actually parallelogram AF, and we're going to put a C right there. Okay? So, actually, AFEB, this parallelogram AFEB, is actually AFCB. Okay? So, we can now say that parallelogram AFCB is contained by the lines AB and BC, because you have line AB and you have line BC, which I know this looks like BE, but it's actually now going to be called BC because the length of BC is equal to the length of BE. Hopefully that didn't get you too confused. Alright. Now let's deal with parallelogram AFDC. It is contained by the lines AC and CB. You say, how is that possible? Because CD equals CB. CD equals CB. Okay? So, we can say that parallelogram AFDC is in actuality parallelogram AFBC. because CD is equal in length to CB. And that's because CBDE is a square. And all four of these lengths, this one here, this one here, this one here, and this one here, are exactly the same. If it's a square, it's going to be exactly the same. Alright? Now, obviously, DEBC is a square. And it's a square on line CB. So, the rectangle contained by ABBC, okay, ABBC, remember now we said it was BE originally, but now it's become BC, so ABBC, the rectangle contained by these two lines right here, this one here and this one here, is the sum of the rectangle contained by ACCB, or better yet stated, ACCB, this rectangle right here, plus the square of DCBE. And hopefully I didn't get you too badly confused. I will tell you more in a future video. If you need any help, just leave a comment below and stay tuned.